The concepts relevant to this activity are mixing together different materials or substances and chemical reaction. And a chemical reaction is when we mix things together and there are changes that we can observe as science detectives. And we're going to mix together two chemicals. This one is a runny chemical. What kind of chemical is that? Is that solid or liquid? That's a liquid. And this one's a powder. It's similar to the sand, but it's smaller pieces. It's a fine powder. What kind of chemical is that one? It's a solid. And this is baking soda and vinegar we're going to mix together in these cups. So we're going to make two mixtures, and there's going to be a difference between the two mixtures. And because when scientists do an experiment, they often like to have something different between the two things they're doing so they can see how that affects what they observe. And in this case, the difference is going to be detergent. Does anyone know what detergent is? Ask the students. And they might know it's used in dishwashing. It's a cleaning liquid. And you could ask them, what do you think is the difference between that liquid and the runny vinegar? And this is a much more gooey liquid. And you could ask for predictions, what happens when you mix vinegar, detergent, with water? And they'll know something about bubbles being produced, no doubt. So the students are going to mix together vinegar and baking soda in both cups, but they're going to put detergent in this cup and no detergent in this cup. And ask them if anyone can read the labels. You might need to get a volunteer to come out and see if they can read the label and tell the others in the class what it is. And emphasise that when they go to the table, they need to look at the labels and see that one says vinegar plus baking soda. It just has two things, whereas this has three things that we're going to add to the cup. Vinegar plus detergent plus baking soda. So the students are going to go to the table and follow the instructions you give them to do the activity. So at the table, the students are going to unscrew the top of the squeeze bottle to open the valve that allows the vinegar to come out. It's a bit like a tomato sauce bottle they might be familiar with. And two people in the group, we're going to share the jobs in this activity. Everyone in the group is going to work together to do the different jobs, and we're going to take it in turns. So one person's going to fill up the vinegar to the mark on the cup, and they're going to give the bottle to another person who is going to fill up the vinegar to the mark on that one. And we're going to put the cups next to each other, and we're going to see that it's got the same amount of vinegar in both of them. Or we're going to shut the top of the bottle when we're finished. And then somebody else, the next job is to put 1 teaspoon, 1 drop of detergent, into the cup labelled vinegar plus detergent and baking soda. Very important to emphasise that we're not going to put any drops of detergent in that cup, because the students will very readily just put detergent in both of them. So yes, one person is going to be very careful and squeeze gently. And watch that just 1 drop comes out and mixes into the vinegar. Always put the lids back on the bottles. All right, and then the group is ready to add the last chemical. Remember to emphasise, does this one say any detergent on it? No, don't add any detergent to that one. We're only adding detergent to that one. And then they're going to add a teaspoon of baking soda to both cups. I'm just going to add one at a time, but it's a good idea to get 2 students to add the teaspoon of baking soda to each cup at the same time, so they can watch what happens and how one reaction goes fast and one goes slow. So another student, you can get one student to be ready with one and put it in, and another student could be ready at the same time to put the other one in. And yeah, doing it at the same time will highlight the contrast between them in how quickly they go, and get the students to listen to the bubbling, watch closely which one bubbles the most, and get them to observe which one goes, or to think about which one goes fast and which one goes slow. And then get them to come back to the floor and discuss the results of the reaction. The discussion for this activity can look at what were the observations they had for the 2 reactions. They both made bubbles, there was fizzing, froth, but also what were the differences between the 2, and which one went fast and which one went slow. And this one went up very fast. The vinegar and baking soda went up very fast and then went down fast. This one went more slowly. It went up slowly and then slowly went down. This was a slower reaction. So chemical reactions can be fast or slow. You can ask, what was the effect of the detergent? It slowed down the reaction, and you could have some discussion. Why would the detergent slow down the chemical reaction? Oh, maybe because it's sticky, and it sticks to the chemicals and slows them down. Imagine if you were swimming through a swimming pool of detergent, it'd slow you down, wouldn't it? So yeah, the detergent slowed down the reaction. And sometimes scientists want a slow reaction. For example, when a doctor gives you medicine, we want that to react slowly in your body so the medicine goes all through your body. You could ask the students which one was the most powerful reaction. They might say this one because it sort of went up more obviously and it stayed up higher, and this one was all over more quickly, so they think, oh, this one was more powerful. But with a bit of discussion, hopefully they can get the idea that it was actually the quick one that was much shorter. It didn't last long, but it was very powerful when it lasted, and it had much bigger bubbles, and it made all the noise. They wouldn't have heard much noise from this one. This made all the fizzing. This had much more energy, so scientists can measure how much energy a chemical reaction's got, and that can be related to, yes, sometimes scientists want a powerful, quick reaction, like, for example, to launch a rocket. So a rocket would work a little bit with its rocket fuel would work. It's a bit like the fuel tank of a rocket, what was going on in this one. And then we can move on to the next activity.